All right, let's talk about efficiency of a condenser coil. This is on page 1222. It says grades of equipment. Not all pieces of equipment you buy have the same efficiency. Some units are higher in efficiency. They cost more, but they save you money. This is a way this happens. As an HVAC tech, you should know this. There is economy, standard efficiency, and high efficiency. Okay, so how do we know what makes equipment greater efficiency? Well, it comes down to the condensing temperature and pressure. Remember, your head pressure, your high side pressure, when it goes up, your compressor works harder and it costs more energy to actually operate the system, okay? So there you go. We got 200 degrees discharge temperature, a superheated vapor coming into the condenser. It starts to condense. 95-degree air goes across the coil and it's condensing at 125. Then it becomes subcooled liquid at the bottom and it's 115. Now, what is the head pressure for that condensing temperature? Okay, the saturated mix of liquid and gas, you can use your PT chart. For that 125, it becomes 410A. If you take that 125 and put it on your PT chart, it's 446 pounds of head pressure. So your condensing temperature on a standard efficiency unit, your book says on 1222, it's not that hard to understand, is the difference between the outdoor temperature and your condensing temperature. So the difference between 95 and 125 is 30 degrees. So on standard efficiency, it's 30 to 35 degree difference. That gives you a 446 pound head pressure. Okay, and remember the head pressure, the more it goes up, the higher it's going to cost to run the unit. Now, if we lowered the head pressure, so let's lower the condensing temperature to 115. That would mean this stayed 95 because you're not changing the outdoor temperature. Mother Nature's got it. It's 95. You ain't changing that. It's 115 can be changed. Let's increase the size of the condenser coil. Okay, that would lower the condensing. So 150, there's different ways to do it. That's for another unit. But right now, let's say we lower that. So the difference between this and this goes down. 20 degrees. The outdoor temperature minus the condensing temperature is 20-degree difference. At 115, what's my head pressure for 410A? Go look it up on your PT chart. It's 390. So with higher efficiency, you're going to have lower head pressure and a lower condensing temperature. That's how that works. And that's all written out on page 1222 right there for you. Okay, it shows you 410A and R22 right there. So lower head pressure by lowering the condensing temperature gives you lower costs to run the unit. All right, that's how that works. The code for this video is Blueberry. Now, I will say this. Your book says you have simple on page 23 charging charts. So let's look at them charging charts right here. I want you to follow along with this, okay? Notice on this chart, on the left-hand side, it says, here's your head pressure. 450 all the way down to 150, okay? Down here, here's your suction pressure. So you know what your red gauge is. You know what your blue low side gauge is. All you got to do now is look at these lines right here, which is what? Your outdoor temperature. So let's say it's 300-degree head pressure. And the temperature outside is 95 degrees. I need a 70-pound suction and it'll be charged correctly. See how easy that is? Okay, these charts are all the same. This one down here says, if you follow along in your book, over here you have your liquid line pressure. Over here is your compressor from your suction line. And here it says temperature outside air. Once again, let's say we got 250 head and a 70-pound suction on a 95-degree day. That'd be charged correctly. Now also on that page, they give you a little thing. It says, after the condensing temperature increases, if this goes up, there is a greater difference between ambient and condensing temperature. So they just saying, if I went from this to this, there'd be a bigger difference. So between 95 and 115 is 20. But between 95 and 125 is 30. So the more the condensing temperature goes up, let's say you got a dirty condenser coil, that pressure is going to go up. All right? The greater the condensing temperature, the greater the head pressure. So that's how the high efficiency works. So this is the stuff that was on page 1222 and 1223. Okay? Now remember this, on 1223 it says, the three things must be considered along with published list of typical operating conditions. What is the load on the outdoor coil? The sensible heat load on the evaporator, and the latent heat load indoor, which is influenced by humidity. Humidity is determined by taking your wet bulb temperature. So what do we do when we're going to check this unit for typical operating conditions on 4011? They give you a list. The first thing you do is turn it on and let it run for 15 minutes. So the system's got a time to stabilize. 6, it says get your superheat. And then look at these charts over here. You got different charts. This one, if you want to follow along on 1224, is right here. And over here is your outdoor temperature. Okay, I need to turn around. But that's the chart. Follow along on this chart right here on the top of page 1224. You have your outdoor temperature. Okay, let's say it's 90 degrees. And it says at the top, the indoor coil entering temperature is, with wet bulb, 64 degrees. We should have 9-degree superheat. See, they got charts for all this. All these different ranges for you, they got typical operating charts. They usually come with the unit. You take the panel off and you got the charts right there. So these help you figure out how to charge it. Now in 1224 it says, when you have no literature or nothing to help you, what do? The first thing is to establish some known condition. Try to see if it's high efficiency, low efficiency. See what the compressor is. Look at figure 4012 right there, 1224. It says approximate full load amps for these alternating current. Let's say you had a 0.5 horsepower compressor and it's single phase, it's 9.8. You can take this and figure out what the capacity of the unit is. Okay? Look at 3. 3-ton motor at 230 should be drawing 17 amps. So if it's doing that, you know it's a 3-ton. See how that works?